Hello everyone, welcome to Reactify Labs. Today we will talk about batch processing. So let's write down the headline. Batch processing. So why are we studying batch processing? It is because while handling processing of some of the information or our systems, we may need to do it in batches. We may not be able to do the real time processing or something else. So batch processing is the best thing that we can do. So basically, let's say if you have a large amount of data which is being generated, but only a few are needed to be processed at that time. So for the remaining data, we may collect the others as well, make them into batches, and then send them all to processing at once during the maybe offload hours or some other time, maybe a fixed time of the day, so that the performance at the peak time can be enhanced. Okay, so that's the role of batch processing. And now that we know about the why, let's talk about some of the formal definitions of batch processing and how it differs from real-time processing, and what are some of the evolving trends in batch processing these days. Okay, so batch processing, what is it? It's a method where data is collected. It's a method where data is collected, processed, and executed. Processed and executed in predetermined sets. In predetermined sets known as batches. Okay. So basically, it's just the data is collected. As I told you before, it's collected, and once the data is gathered, the predetermined set size is reached, then it forms a batch, and then batches are sent for processing. It contrasts with real-time processing. It contrasts with real-time processing, offering efficiency in handling large volumes of data. Offering efficiency in handling large volumes of data. So, what are the key components of batch processing? So, first one is batch jobs. Batch processing revolves around the concept of batch jobs, which represent a collection of tasks or processes executed sequentially. So, what is batch? Batch means it's a collection. Okay, instead of processing one or two things at a time, we'll form a batch. So, batch jobs. Next is input data. Input data is organized into batches, typically processed from a designated source, such as database or files. And the next is a processing engine. So, a processing engine orchestrates the execution of batch jobs, ensuring tasks are carried out in a systematic manner. Okay, now that we know about the key components, let's talk about the workflow of batch processing. So, workflow goes like this. First step is data collection. Obviously, if we have to process the data, we have to collect it. So, the process initiates with the collection of data in batches from various sources. Next comes job execution. Batch jobs are executed sequentially, performing operations on the collected data. And next is output generation. So the processed data generates outputs which may include reports, updates, or new data sets. So it's not anything new. It was obvious, right? There will be data collection process, then there will be the execution of batch job, and there will be output generation. Okay. Let's talk about the advantages of doing batch processing. So batch processing excels in handling large volumes of data efficiently, optimizing resource utilization. So basically efficiency. So batch processing handles large volumes of data efficiently and thus optimizes the resource utilization. That's why it is efficient. Second advantage is scalability. The approach is scalable, making it well suited for processing vast data sets without significant performance degradation. And next comes error handling. Batch processing provides robust error handling capabilities, allowing for systematic identification and resolution. Okay, let's talk about some of the use cases where batch processing is used. Use cases. One is financial processing. Batch processing is widely employed in financial institutions for tasks like end of day processing, reconciliations, and report generation. And next is data warehousing. In data warehousing, batch processing is instrumental for ETL operations. ETL means extract, transform, load operations, thus ensuring data consistency. So it does not have all the advantages, it comes with its challenges as well. So let's talk about some of the challenges of batch processing. Latency is one such challenge. Batch processing introduces latency due to the periodic nature of job execution, making it less suitable for real-time requirements. Because the data is not processed in real time, it's processed at a later stage, so there will be some latency, obviously, right? Let's say data is generated today and it has to be processed at night, so latency is there. You won't be able to see the results of that processed data until next day. Next comes complexity in scheduling. So coordinating and scheduling batch jobs, especially in complex systems, can be challenging and requires careful planning. So let's talk about how batch processing differs from real-time processing. Batch processing versus real-time processing. So real-time processing focuses on immediate data processing and response. Okay, if I have to write it down, I'll say real-time processing focuses on immediate data processing and response. Catering to applications with stringent time constraints like stringent time constraints like live streaming, monitoring systems, etc. Right? So real-time processing is generally good for the times when you need real-time data processing. The best example that I can do is, let's say, you are using Instagram. Okay. and you open somebody's profile. So when you open somebody's profile, then what it does is, depending on your uh, or actually no, not that, better example would be, instead of profile, let's say you are watching a short, some shorts. So what happens is, let's say you liked that short very much. Okay, so you liked it so much that you watched it multiple times. Instagram has not shorts, right? Instagram has reels, sorry. You are watching reels. So you watched that reel multiple times, you shared it with multiple people, you liked it, you commented on it, then with that, Instagram knows that okay, you liked this thing very much, so it will try to show you those same content. So what happens is, let's say you scroll 2 3 more reels. By the time, in the background, Instagram has done the real time processing of the previous reel and has gathered more such reels of the similar category, and it will keep on showing those reels to you. So this is the best example of real time processing. You will see it within 2 minutes or even less than that. So those are the cases when real time processing is used. Whereas batch processing emphasizes efficiency over immediacy. Sorry, efficiency over immediacy. Okay. Batch processing, as I have told before, so I'm not going to write about it. It is well suited for scenarios where data can be collected, processed, and analyzed in non-real time, such as nightly data backups, so data backup at night, monthly financial reporting, or large-scale data analysis. Okay, let me write it down. So batch processing emphasizes efficiency over immediacy. Casey. Immediacy. Batch processing emphasizes efficiency over immediacy. Okay, it is well suited. It is well suited for scenarios where data can be collected, processed, and analyzed in non-real time, such as nightly data backups, monthly financial reporting, or large-scale data analysis. So these are the cases where this batch processing is used. And there comes something called hybrid approaches also. So hybrid models. Hybrid models are the combination of batch and real-time processing. So hybrid models are emerging to reconcile the advantages of both approaches. Reconciles the advantages of both batch processing and real-time processing. So these models integrate elements of batch processing and real-time processing, providing a flexible solution that can adapt to diverse processing needs. Okay. Now let's talk about some of the real-world systems in which batch processing is used. Uh, One is billing systems. So billing systems frequently rely on batch processing for tasks such as generating invoices, processing billing cycles, and handling large volumes of transactional data. This approach ensures accuracy and consistency in financial operations. Next comes large scale data analysis. Batch processing is pivotal in large scale data analysis scenarios. Organizations leverage batch processing to derive insights from extensive datasets, conduct historical trend analysis, and generate reports. This is common in fields like business intelligence, scientific research, and market analysis. Now, let's talk about some of the evolving trends in batch processing. So, first one is big data processing. So, batch processing is pivotal in big data analytics. As datasets continue to grow exponentially, batch processing enables organizations to efficiently analyze vast amounts of information, extracting valuable insights, and supporting data driven decision making. Complex queries and aggregations also. Big data batch processing is well suited for handling complex queries and aggregations over extensive datasets. This capability is crucial for extracting meaningful patterns, trends, and correlations from diverse and massive data sources. If I have to explain it, so as you must have heard, data is the new oil, right? And we know that there is a tremendous amount of data that is getting generated every year from different sources, so we don't even know how much it is. So even if there is one system, let's say a Facebook or Instagram, which has billions of users, so when they generate data sets, so and they need to also do queries on it. Even if we have, let's say, a data set of size 1 million, a simple query is taking some seconds, and if it's a complex query, it will take some tens of seconds, and if it's a very complex query over 1 million or 10 million data set, it might take a few minutes, more than that also. So assume big data where we have billions of data points. If we have to do some complex queries on it to derive something, to see trends or anything, this will take a lot of time. So that's why batch processing is good for them. Once we have all the data, then during the offload hours, we will just process the data and do nothing. Okay, for example, let's say the data is in India. So Facebook has India data. So it's in India server. It knows that during the day a lot of people are active. So during the night means after everybody is sleep, let's say 2 a.m. or after 4 a.m. So it knows that okay, still there may be some people awake, but the load is a lot less. So what it does in that time is they use other resources for batch processing in the offload hour. So that's how big data is helpful in this deriving meaningful insights from the data, handling complex queries, and a lot of things. Okay. Next comes cloud-based batch processing. So cloud-based batch processing. The adoption of cloud platforms has revolutionized batch processing definitely. Cloud services provide scalable and cost-effective solutions, allowing organizations to scale their batch processing capabilities based on demand without the need for extensive infrastructure investments. Cloud-based batch processing has the advantage that it offers resource flexibility and thus enables organizations to allocate and deallocate computing resources dynamically. This adaptability is particularly beneficial for managing variable workloads efficiently. So it's the same example as the Facebook. So let's say it has this one where there is data, and it has the other server where it has to cater to user requests or a lot of things. So let's say it has a fixed number of resources, let's say n resources. So during the peak hours, what it does is it gives, let's say, m resources to this and k resources to this. So basically k plus n is k plus m is equal to n. Okay. And for the this load hours, means during the daytime for the India market, let's say m is much greater than k. Okay. But at the night time, what happens is this becomes, let's say, p, this becomes q, and p becomes much greater than q because of the dynamic resource allocation. So Facebook uses these resources, the resources it was using here, it diverts them to here and keeps some here during the offload hours just to process user requests if they come. Okay. So that's it. about the cloud-based batch processing, let's talk about MapReduce now. So what is MapReduce? So MapReduce is basically a parallel processing programming model, and it's a cornerstone of batch processing in big data environments. It divides tasks into two phases: the map phase for processing input data and the reduce phase for aggregating results. This parallelism enables efficient processing of vast datasets. MapReduce distributes computation across a cluster of nodes, facilitating parallel execution and improving overall performance. This distributed nature makes it suitable for handling large-scale data processing tasks. So MapReduce is basically, it has two steps. First one is map, second one is reduce. So it processes the input data. Okay. So what it does is it maps the input data with different types of tasks, and reduce phase, after the processing happens, the reduce phase aggregates the results. So this is all about map reduce. I'm not talking in detail about MapReduce. I'll make another video if you guys want. Please let me know in comments if I should make a detailed video on MapReduce or not. Okay. Next, there is one more thing called Apache Spark. This also needs a in-depth video in itself. So please let me know if I should make one on this as well. In short, let's talk about this. Apache Spark is an open source distributed computing system which has emerged as a powerful tool for batch processing. One of its key features is in-memory processing, which allows Spark to store intermediate data in memory, resulting in faster and more efficient data processing compared to traditional disk-based batch processing. Apache Spark offers a versatile and user-friendly API supporting batch processing as well as interactive queries, stream processing, and machine learning. Its versatility makes it a preferred choice for organizations seeking a unified and comprehensive big data processing solutions. It also provides fault tolerance. Spark incorporates fault tolerance mechanisms, ensuring reliability in the face of node failures. This enhances the robustness of batch processing workflows, especially in distributed computing environments. Okay, so what were the key features of Apache Spark? Is in-memory processing first. It does in-memory processing. It's easy to use and versatile. Versatile, and it's fault tolerant. Fault tolerance. Okay, so this completes the batch processing. So basically, if you see, we have big data processing model, we have cloud-based processing model, and these are the tools that we use for batch processing. So this is a tool, this is a tool. I might talk about this in one of the other videos. Yeah. So yeah, please let me know in comments what you want more to focus on. I will go into the details of that topic. And this completes everything about batch processing. I hope this gives you a clear idea about what is batch processing, how it differs from real-time processing, why batch processing, what are the advantages of using batch processing, and what are the use cases where batch processing is used, and what are the tools that use batch processing that like not use that help in doing the batch processing. So that's it. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.